This is the screencast for section 2.4, example 3. We're going to use synthetic division. Synthetic, like you've heard of like synthetic materials, they're kind of a substitute, a pretend material, not the real thing. So we're going to use this pretend version of division to make division a little bit easier for us in this section. Synthetic division starts by writing out the function I'm going to divide. So I'm going to write out just the coefficients of each term in that function. So I'm going to write 2, then -3, then -5, then -12. Now I'm dividing that function by x minus 3. So in a little box off to the side here, I am going to put positive 3, the k value, x minus k, x minus positive 3. First step in synthetic division is to drop the first term of my function down to the bottom of the bar. 3 times 2 is 6, so I'm going to write a 6 up here. Now -3 plus 6 is 3. This is a whole bunch of multiply, add, multiply, add, multiply, add, multiply, add. So now I'm going to multiply 3 times 3, which is 9, and then add. -5 plus 9 is 4. 3 times 4 is 12, -12 plus 12 is 0. So now we have to decode what this means. 0 here is the remainder. 4 is the constant term. This term goes with x, this term goes with x squared, and then if you had more terms, it would keep going. So you always start on the right with the remainder and then build from there. Well, part of this problem asks us, the end of this problem asks us to write a summary statement in fraction form. So my summary statement in fraction form has to start out with the fraction of division that I did. I did 2x cubed minus 3x squared minus 5x minus 12, and I divided that synthetically by x minus 3. What I got was 2x squared plus 3x plus 4, and then plus a 0 remainder, which I don't have to write. If I had a remainder like 1, I would have written 1 over, let's see, I divided by x minus 3. But I don't have a remainder, so I wouldn't write that here. The now try problem for example 3 is number 7. We're going to synthetically divide x cubed minus 5x squared plus 3x minus 2 by x minus 1. So I'm going to start by writing out the coefficients of the function I'm dividing. So I have 1x cubed minus 5x squared plus 3x minus 2. Now if I was missing a term there, I would still need to put a 0 in its place. You have to have a placeholder for each of the terms in decreasing order of exponent. I am dividing this function by x plus 1, so my k value is -1. This is x minus k, or x minus -1 to get the x plus 1. Step 1, drop down the first term. Let's see, -1 times +1 is -1, so I multiply, add, -6. -1 times -6 is 6, add 9. Times -9, add -11. This time I have a remainder. It's -11. So to write my statement, my summary statement in fraction form, the original fraction I divided by was given to me this time. X cubed minus 5x squared plus 3x minus 2 all over x plus 1, so divided by x plus 1, got me, okay, so here's the weird part, because I need to read from left to right, but I need to figure out what that is from right to left. If this is the remainder, 9 is the constant term, -6 are the x's, so 1 is the x squared. So that would be x squared minus 6x plus 9, and then I have 11 as a remainder, so minus 11 that remains to be divided by x plus 1. There's my summary statement in fraction form.